Hello students, hope you're doing well. Today we're going to discuss what is cluster analysis. Cluster analysis has emerged as a powerful tool in data analytics analysis, offering valuable insights into complex data sets. By grouping similar data points into clusters, this technique enables business and researchers to uncover patterns, detect anomalies, and make informed decisions. This article aims to provide in-depth understanding of cluster analytics, including its definition, underlying algorithms, applications across various industries, challenges, and future prospects. Throughout this course, readers will gain a comprehensive perspective on the potential of cluster analysis and its role in shaping data driven strategies. So let's take a look on table of contents. First we have the introduction, then we have to discuss what are the types, pre-processing and feature of cluster analysis, evaluating application challenges and ethical issues, best practices, and then we have future trends, and then we close our topic by our conclusion or end mark. So, what is cluster analytics? Cluster analytics, also known as clustering, is a data analysis technique that involves grouping similar data points into clusters based on their characteristics and proximity. It aims to identify inherent structures or patterns within datasets without requiring labeled data. By clustering data, organizations can gain insights into relationships and similarities between data points, enabling them to make informed decisions and extract meaningful information from complex datasets. Importance of cluster analytics. Cluster analytics play a critical role or play a crucial role in various fields, including business, healthcare, finance, social sciences, and many other disciplines. It offers valuable insights into customer segmentation, fraud detection, anomaly detection, image recognition, and much more. By uncovering hidden patterns, cluster analytics aid in making informed business decisions, optimizing processes, and identifying outliers or anomalies. It also helps researchers in discovering patterns and trends in vast amount of data, leading to advancement in various scientific domains. Objective of clustered analytics is to provide a comprehensive understanding of cluster analytics, covering various aspects such as algorithms, pre-processing, evaluation, applications, challenges, best practices, and future trends. By exploring these topics, the learners will gain a holistic view of cluster analytics and its potential application in different industries. So we're going to discuss different types of clustering algorithms. First one we have k-means clustering. K-means is one of the most popular and widely used clustering algorithms. It partitions data into predetermined number of clusters based on minimizing the sum of squared distances between data points and their cluster centroids. Number two, we have hierarchical clustering. Hierarchical clustering builds a three builds a tree-like structure of clusters where each data point starts as an individual cluster and is successively merged based on their similarity. It can be agglomerative, bottom-up, or device top-down. Third one we have density-based clustering. Density-based clustering algorithms such as DVScan identify cluster based on the density of data points. They group together regions of high density, separated by areas of low density, and are robust to noise and outliers. Fourth one we have EM, expectation maximization. EM clustering is based on the principle of maximum likelihood estimation. It is commonly used for clustering tasks involves probabilistic models such as Gaussian mixture models, such as short form GMMs. Then we have DVScan, density based spatial clustering of application with noise. DBScan is a density-based clustering algorithm that groups together data close to each other and separate noise points. It is effective in discovering clusters of arbitrary shape. Other clustering algorithms include spectral clustering, fuzzy clustering, self-organizing map, and affinity propagation. Each algorithm has its strengths and weaknesses, and the choice depends on the specific characteristics of data and desired outcomes. So, our next segment is pre-processing and feature selection. Internal evaluation metrics. Sorry. Data cleaning and transformation. Before applying clustering algorithm, it is crucial to pre-process the data by removing missing values, handling outliers, and transforming variables if needed. Data cleaning ensures the quality and reliability of the clustering results. Feature scaling and normalization. To prevent bias in clustering results, it is often necessary to scale or normalize features. This step ensures that all features contribute equally to the clustering process and prevents dominance by features with larger scales. Dimensionally reduction techniques. High dimensional data can pose challenges for clustering algorithms. Dimensionally reduction techniques like principal component analysis, short form PCA, or TSNE, can be employed to reduce dimensionality of the data while retaining its essential characteristics. Feature selection methods or model. Feature selection helps identify the most relevant features for clustering. It estimates irrelevant or redundant features, improving clustering performance and interpretability. Techniques like filter models, wrapper models, and embedded models can be employed for feature selection. Our next segment is evaluating clustering results. Internal evaluation metrics such as Kelansky, Harpers Index, and Davis-Boulding Index assess the quality of clustering results based on data alone. These metrics quantify the compactness and separation of clusters. External evaluation metrics such as RAND index and Foulkes-Mallows index compare clustering results to ground truth or known level when available. These metrics measure the similarity between the clustering outcome and the two classes. Visualization techniques such as scatter plots, heat maps, and dendrograms help interpret and visualize clustering results. They enable the exploration of cluster structure, outliers, and relationship between data points. Applications of cluster analytics. Marketing and customer segmentation. Cluster analytics revolutionize marketing strategies by segmenting customer into distinct based group on their purchasing behavior, demographic or preferences. This enables targeted market campaigns, personalized recommendation, and improve customer satisfaction. Fraud detection. By identifying patterns and anomalies in financial transactions, cluster analytics assist in fraud detection. Unusual behavior or suspicious patterns can be detected by clustering similar transactions and highlighting outliers or deviations. Healthcare and medical research. In healthcare, cluster analytics aids in patient segmentation, disease clustering, and drug discovery. It helps identify patient subgroups for personalized treatments, discover disease patterns, and analyze gene expression on data. Image and pattern recognition cluster analytics. Find application in image and pattern recognition when it groups similar images or patterns together. This allows for image categorization, object recognition, and image interval system. Anomaly detection is the identification of rare events or outliers in the data. Cluster analytics help detect anomalies by clustering normal data points and identify those that do not fit into any cluster. Last one, we have social network analysis. Contributes to social and network analysis by identifying communities or groups within the network. It helps understand social interactions, information flow, and influence patterns, benefiting areas such as marketing, sociology, and counterterrorism. Next, we are going to discuss challenges in cluster analytics. Determining the optimal number of clusters, selecting the appropriate number of clusters is challenging task. Several methods such as elbow method, Sit-Houghton analysis, and gap statistics can be employed on estimate optimal number of clusters. Handling high dimensional and sparse data high dimensional. High dimensional and sparse data poses challenges in clustering and due to course of dimensionality. Dimensionality reduction technique and specialized clustering algorithms designed for such data can help mitigate these challenges. Dealing with outliers and noise outliers can significantly impact clustering results. Robust clustering algorithms, outlier decision techniques, and pre-processing steps can be employed to handle outliers and minimize their influence. Interpreting and validating results can be subjective and challenging. Expert domain knowledge, visualization techniques, and standard evaluation metrics can assist in interpreting and validating the clustering outcomes. Scalability and efficiency. With the ever increasing volume of data, scalability and efficiency become important considerations. Developing scalable clustering algorithms, parallel processing, and distributed computing networks are crucial to handling large scale datasets. Practice for effective cluster analytics. Understanding the domain and gaining domain knowledge and understanding two characteristics of data are vital for effective cluster analytics. This enables the selection of appropriate algorithms, preprocessing techniques, and evaluation metrics. Selecting the appropriate clustering algorithms, choosing is the might clustering algorithm depend on the data properties, design outcomes, and available resources. Experiment with different algorithms and understanding their strengths and weakness help in making informed decisions. Interactive reinforcement and validation cluster analytics is an interactive process that requires refinement and validation. Interactively adjusting parameters, pre-processing steps, and evaluate the results help in moving the quality of clustering outcomes. Incorporate Incorporating expert knowledge. Incorporating expert domain experts can provide valuable insights and guidance throughout the clustering process. Incorporate expert knowledge and feedback can enhance. It is the importance to regularly update and retain model with fresh data. Then we have future trend and advances. Integration with artificial intelligence and machine learning, cluster analytics is expected to integrate with other AI and ML to enhance its capability. Combining cluster analytics with predictive modeling, deep learning, and reinforcement learning can unlock new avenues for insights and decision making. Streamlining big data processing. As the volume of data continues to grow, efficient processing and analysis of big data become crucial. Advancement in distributed computers, parallel processing, and cloud-based solutions will enable faster and more scalable clusters, incorporating contextual and temporal information, integrating contextual and temporal information into cluster analytics can provide deeper insights and improve accuracy. Considering the dynamic nature of data and capturing temporal patterns can enhance the understanding of complex system, privacy and constitution. As cluster analytics deal with the sensitive data, privacy and ethical consideration become paramount. Striking a balance between data utility and privacy preservation while ensuring ethical use of data will be critical focus for future advancement. Human centric cluster analytics. Future development may focus on marketing cluster analytics more centric emphasis user interaction, interpretability, and explainability. User-friendly interactive visualization and user-driven clustering process will empower users to harness the full potential of cluster analytics. So, what is our end mark or conclusion for cluster analytics? That is, it is a powerful data analysis technique that groups similar data points into clusters, providing valuable insights to complex datasets. It plays a significant role in diverse domains such as marketing, healthcare, and detection fraud, etc. Importance of cluster analysis in data-driven world. In today's data-driven world, cluster analytics enable organizations to uncover hidden patterns, detect anomalies, and make informed decisions. It empowers researchers to explore and undertaking tools, datasets to an advancement in various scientific purposes. Future outlook and potential impact with among four advancement in algorithm computing power and organization with other techniques, cluster analysis is paid for significant growth and impact. Its potential to revolutionize future of data by manufacturing and its application. In conclusion, cluster analytics has emerged as a crucial tool for data analysis, offering powerful insights to complex disasters. Organization sessions can harness the full potential of cluster into data-driven strategies and unlike valuable insights. So that's the end of the lecture clustering analysis. I hope you guys understand all the important key terms and theories related to cluster analysis. If you guys have still any question, you are always free to ask me anytime. I will reply them your messages and queries within short time. So take care. Have a good day.